Mutual induction work primary coil when AC flows through the primary coil, magnetic flux in the primary coil changes. When magnetic flux in the primary coil changes, magnetic flux in the secondary coil also changes. Two coils self induction L1 L2 ayirunda mutual induction vandu K into root of L1 L2 varum. K is a constant. K is a constant called coupling constant. Coupling constant. Two coils self inductance L1 L2 ayirunda mutual inductance vandu K into root of L1 L2. K vandu coupling constant. If both coils wound over same core, two coil mein same core wound aayachana, the coupling constant is 1. Coupling constant is 1. If both coils, one coil wound over the other, coupling constant is 1. Then mutual inductance equal to root of L1 into L2. If the axes of the coils are mutually perpendicular, the coupling constant equal to 0, the mutual inductance equal to 0. First case, the coils are inductively coupled, and second case, the coils are inductively isolated. The coils are inductively coupled and the coils are inductively isolated. But in a transformer, the coils are inductively coupled. So, in the figure, this is a wrong figure. This is an ideal figure. Actually, the correct transformer same core two coils wound. Both coils are wound over the same core. So, symbolically, for convenience to understand primary coil and secondary coil, convenience just for convenience in the diagram in the and practically in the both coils wound over the same core. Two coils same core wound action. One coil is wound over the other. The coupling constant become 1. Then mutual inductance will be maximum. And this is, in this case, the coils are inductively isolated, inductively coupled. Axis mutually perpendicular, coupling constant 0. So there is no mutual inductance. For mutual inductance maximum if both one coil is wound over the other, mutual induction will be maximum. Okay, ma? Okay, ma? Okay. So transformer consists of two coils wound over the two well-insulated copper windings wound over the same soft and core, primary coil and secondary coil. When AC passes through the primary coil, magnetic flux in primary coil changes. By mutual induction, magnetic flux in secondary coil also changes. When magnetic flux in secondary coil changes, an EMF is induced in the secondary coil. So, primary coil, voltage in primary coil equal to minus of number of turns in primary into d phi by dt. d phi by dt, rate of change of flux in a single turn. Primary coil n turns irukku. One turn rate of change of flux d phi by dt into number of turns multiply action total EMF varula. And voltage in secondary equal to number of turns in secondary into d phi by dt. Inge oru chinna oru practical vaadu konja difference irukku. Theoretically idu rendume same flux in a single turn in primary d phi by dt, flux in a single turn in primary is equal to flux in a single turn in secondary. Practically they are not same. Theoretically rendume same. So when one coil is wound over the other, first coil flux complete second coil. So, flux in a single turning primary is equal to flux in a single turning secondary. And the higher level, higher level. This is actually in the 5P and 5S in the higher class. Number of turns in primary into d 5P by dt. 5P is flux in a single turn in primary, and 5S is flux in a single turn in secondary. Practically in the and syllabus so we assume that flux in a single turn in primary is equal to flux in a single turn in secondary. So only difference is number of turns. And practically because some flux is lost. Practically correct value almost 80-86% flux. Primary level of flux is 80-86% flux in the secondary level. But theoretically saying flux in a single turn in primary is equal to flux in a single turn in secondary, theoretically. So voltage in secondary by voltage in primary is equal to number of turns in secondary by number of turns in primary. The ratio is called, this is called transformer ratio. Voltage in secondary by voltage in primary equal to number of turns in secondary by number of turns in primary. This is called transformer ratio. Suppose you have to step up the voltage. Power station voltage step up. When voltage is increased, the current intensity will decrease. Because power equal to current into voltage. When you increase the voltage, the current intensity will be decreased. Current intensity decrease Joule seating effect and the I square RT. So Joule seating effect will reduce. So you can prevent, you can reduce or you can minimize the power loss. That is why the voltage is, the power is transmitted always at high voltage. Power is transmitted at a high voltage because by increasing the transmission voltage, you can reduce the transmission current. So transmission current reduce heat produced in the transformer, in the supply line can be reduced. The energy loss can be reduced. Okay. In a step up transformer, number of turns in secondary will be more than number of turns in primary. In a step down transformer, number of turns in secondary will be less than the number of turns in primary. Okay. So, don't worry.